This is the Perception Project by Royce, Matt, Apollonia, and Henry, that we integrate pieces of information into meaningful wholes, specifically an organized whole. As we look straight ahead, we cannot separate the perceived value into our left and right fields of vision. We always perceive a seamless scene due to this idea of gestalt. As you can see here, I have pieces of a jigsaw puzzle, and this shows gestalt perception because you need to piece the smaller pieces of the puzzle together to form the bigger parts and therefore complete the puzzle.
Is a form of perception in which the human eye system distinguishes between significant figures or objects and their background environment. Essentially, the focus of your attention will be considered on the figure, and while the other objects in the visual field will be the ground. So in this picture, you are going to be focusing on elephants up close, while the trees and everything else in the background are going to be blurred out, and they are going to be the visual background.
These are the rules of perceptual organization and grouping. The first one is proximity, the tendency of the brain to group stimuli together based on their proximity or distance from one another. In the image shown here, there are 4 pencils, but the brain automatically perceives them to be 2 groups of 2 pencils due to their closer distance to one another between the first 2 pencils and the second 2 pencils, as seen with the larger gap between pencils 2 and 3, which characterizes these groups. Continuity, and this is how the brain perceives cohesive, continuous patterns over interrupted, disconnected ones. And continuity is seen in these beads in the image shown above, because the brain perceives the multiple dots laid out as a smooth, continuous line pattern, which creates a collective shape rather than just being multiple dots laid out in a random pattern. The brain ensures to group these dots together in a way that can be perceived as a line. The third perceptual organization is closure, and this is the brain's capacity to fill empty gaps in order to perceive a whole image in the absence of space. In this image, there are 4 circles, each having the corner of a square cut out into them. And when arranged in this way, the brain perceives the empty gaps left by the circles as a square, because that is how closure perception works with the brain. It uses the empty space left by these objects to fill in a whole image. And in this case, it would be a square. We have similarity perception. And this is the tendency of the brain to separate stimuli with certain similar traits into groups. Here in this image, rather than simply seeing 8 onions as a whole, the brain groups it into 2 groups of 4 based on each group's similar color, and that would be red and white. So it would differentiate the 4 red onions and the 4 white onions into 2 separate groups.
Binocular cue is a depth cue such as the returnal disparity that depends on the use of your 2 eyes. Binocular cues create a 3-dimensional image greater than what a singular eye could display of objects that we see each and every day. So an example of a binocular cue would be if you hold your thumb out in front of you, you take both your eyes, you close one, open it, close the other, open it, and you might see that your thumb will move in those different pictures. Your eyes are approximately 2¼ inches apart normally, and this causes a slight change in what your eyes see and what they depict of the 3D object of your thumb. So when you close your eyes, the object moves, and when you open them, it moves again. And the eyes see a different location of the finger due to returnal disparity.
Binocular cues are clues that allow us to see depth through one eye. To further describe this, it would be depth, distance, light, and shade, and 3-dimensional cues available to each eye individually. Some examples of binocular cues would be relative height, relative size, interposition, relative motion, finger perspective, and light and shadow. For example, relative motion is as we move, objects that are fixed may appear to move. For example, if you're in a car and you're surrounded by buildings, the building will appear to move with you. The further the object is from the fixation point, the faster it will seem to move. And as you can see here in this video, I'm at the fixed point, and I'm moving to the side from this beam, and the beam seems as though it is moving, and this is an example of relative motion.
Another perception that we have here is motion perception. Motion perception comes in many forms and can ultimately be identified in 3 forms. Understanding that an object from afar seeming to enlarge is merely moving closer to you is simply one example of the brain's ability to perceive motion. Another is how mind identifies how quickly objects of the same speed but different sizes appear to travel. Larger seem slower and smaller would seem faster. A final piece of motion perception that must be mentioned is the illusion of movement that the brain perceives when still pictures are played in incredibly quick succession, which is also known as animation. So in this video here, you'll see a car driving away at a distance. After watching this video, although the car appears to be shrinking, our brains can understand with its motion perception that it is merely increasing its distance from the eyes via motion, rather than actually shrinking as an object.
That's where we are able to recognize an object as itself, regardless of physical changes. There are 4 main changes, and each one is known as an individual constancy. So there's color constancy, which is us being able to recognize an object, even if it appears to change color. For example, a white ball having a red tint being put under a red light, but still being white. And brightness constancy, which can be demonstrated by putting the same white ball in the shade, which makes it look darker, but it's not. This is an example of both of those things. There's also size constancy. Size constancy is where we can recognize the same object, even if it looks smaller or larger, based on its proximity to us. And shape constancy, where we can identify the same object, even if its size is different, and color distorted to make the shape look different.